Welcome. In this video, I'm going to be discussing direct proportionality. Let's start off with the meaning. What is direct proportionality? Direct proportionality is used to describe the relationship between two quantities. That is, changes between two quantities. For example, let's take a cup of coffee and the price of a cup of coffee. So if one cup of coffee costs $3, what will 2 cups cost? 2 cups will definitely cost $6. 3 cups will cost $9. Now, when you look at this relationship, you see that as you increase the number of cups, you increase the price of cups. Now, this is called direct proportionality. So direct proportionality is where the increase in the quantity or in the size of one quantity results into the increase in the size of another quantity. We can have some other examples. Let's say the price of books and the number of books, or we would say this one is not general, like it's not correct for everyone, but it's generally correct. Usually the someone's height versus their speed in swimming or versus their speed in running. The taller the person is, the faster they run generally. So all of that is direct proportionality. Now, one of our aims today is how do we establish a condition for direct proportionality. So if you're given values of a number of quantities, how do you know if those quantities are directly proportional? One, we are going to use tables. So we are going to determine from a table of values whether any two values are directly proportional. For example, the following table shows the relationship between the number X of books bought and the total cost Y of the books. Our first question is complete the following table. So we have X values, we have Y values, we are required to determine Y over X. Now, my Y in this case is 5, my X is 1. So Y over X here would be 5. My Y is 10, my X is 2. That is a 5. My Y is 15, my X is 3. That's a 5. I think you can already see that all of them are going to be 5. So this brings me to condition number 1. If I can get the values of one quantity over the other quantity and I'm getting a constant. Constant basically means the same number. In our case, it's 5. This means that X and Y are directly proportional. I hope that makes sense. One of the conditions for proportionality is when I get one value divided by the other, I should get a constant. For all of the corresponding values, I should get a constant. Now let's investigate another one. Now part of our question is to plot the corresponding values of X and Y. You can use these scales. Now in this example, they've given you scales, but some questions you're going to get, you're required to determine the scale on your own. One of the things you need to remember about the scale, the intervals are the same. For example, here we are skipping 1, which means that I should go 0, 1, 2, 3, 4, 5, 6, and so on. Your scale can't be 0, 1, 3, 5. The intervals have to be the same. Likewise, when you look at the vertical scale, that's the y-axis, it's 5, 10, 15, 20. The intervals are 5, 5. For this question, you need graph paper. You need to plot this accurately, okay? You need to plot this accurately. Hence, you need graph paper. Okay, our first question is plot the corresponding x and y values, and because you want to get a graph. So when x is 1, y is 5. When x is 2, just a minute. When x is 2, y is 10. When x is, I need to be able to write here. When x is 2, y is 10. When x is 3, y is 15. When x is 4, y is 20. When x is 5, y is 25. And when x is 6, y is 30. Okay. After, we need to join them with a line, but I'll do that later. 1 hour, this is done. Our third question is, what can you say about the points you have plotted in question 2? Okay, what do you notice about the points you've plotted in question 2? You should notice that this is a straight line. They are along a straight line, okay? They are along a straight line. At this point, you need to use a ruler and join them. I do not have a ruler currently in the board, so I'm going to join them with free hand. But if you're doing them, please use a ruler. Okay, so now that's my line. My points are along the line. This other question is, write down an equation connecting x and y. Now from this, you need to use your previous knowledge on equations of straight lines. If a line is going through the origin and it's like that, how do you determine this equation? How do you determine the equation of this line? One, you need to get the gradient, basically changing y, over changing x. So if I have my equation, which is like this, I need to get the gradient. This is my change in y, and this is my change in x. So my gradient would be any 2 points. If I subtracted them, I would get the change in y. So let me draw a very small triangle over here, and one over there. I have my change in y, 25 minus 15. And that is going to be 25 minus 15 divided by my change in x over here is 5 minus 3. So this is going to be a 5 minus 3. So this is going to give me a 10 out of 2, which is a 5. This is my gradient. I could have just seen it straight away from my table that's a 5. So the relationship over here is going to be y, because this is my y. My relationship over here is going to be y equals to 5x. That's why when x is 1, y is 5. when x is 2, y is 10. So 5 times 2, your y would be 10. And that is the relationship, or that's the equation connecting x and y. I hope we are still together on the same page. So our fifth question is, how would you find the value of y when x is 8? Now you can do this in two ways. One, you can use your graph. You want the value of y when x is 8. First way is substituting here. So if my y is 5x, I'm going to substitute my x as 8. So my y is going to be 5 times 8, which is 40. Now since y is money, that's going to be $40. And lastly, does the graph of the equation in question 4 pass through the origin? The origin is 0, 0. Yes, it does. How do you know that? If we had not plotted it, all equations which are in the form y is 3x, y is 2x, y is x pass through the origin. Okay, and that means that when x is 0, y is 0. Get to think about it. If you bought 0 books, you would spend $0. Okay, so what did we talk about? Proportionality. Direct proportionality is basically used to describe relationship between two quantities. And for direct proportionality, when one quantity increases, the other quantity also increases. For example, price of books and number of books. When number of books increases, price also increases. And secondly, we can determine whether two quantities are directly proportional by using a table. So if you get the one value of the quantity divided by the corresponding value of the other quantity, you should always get a constant, like we saw here. And the other one, if you plotted a graph, it should be a straight line through the origin.